before we start the session and introduce John Thompson, I want to give a special attention to David. David Strang is a CEO of Ero Copper, but more than that, much more than that, he was the last resource economist that's graduated from Stanford in 1991. And so he's a very special person. He's also, Ero Copper is also a founding member of Mineral X, which is a very special position. And this week, I've been amazingly surprised, or maybe I shouldn't have, in how Dave got involved in all of the science that we were doing in the special workshop that we had for a whole day long on Tuesday. And so with them, we're really, again, have their amazing data available to us and do the science that we want to do with that data. And so because David is a founding member, but also because he is a Stanford graduate, and we only reserve those things for Stanford graduate, we're going to give David the patch. Now, why am I giving the patch? Wait, because he has shirts on with all kind of patches from Canada, Ero Copper. So this is one you want to put on right in the front near your heart. Okay, thanks, David. Okay, so let's go in here. Very super enthusiastic about this session. We want to invite to the stage our moderator, John Thompson, who is running a consulting business out of Vancouver, but also combines his academic experience as honorary professor of sustainable resources at the University of Bristol, and prior at Cornell University and University of British Columbia. With 35 years of experience in the mining exploration, John has a diverse leadership roles in organizations such as Tech Resources, Genome BC, the World Economic Forces Forum, the Society of Economic Geologists, and Canadian Mining Innovation. And everyone that knows John is like, he's an amazing person to work with. We had a meeting, and he, to our non-geological audience, gave a really nice overview of magmatic sulfide as well as porphyry copper systems. And it's always lovely to be working with John, and those who know him would agree with me in that. John, please.
Well, thanks very much, Jeff. It's terrific to be working with you and with the Mineral X team, and it's a pleasure to be here to chair this session. And I should say I'm also very fortunate to be here and very proud to be here because I have a very strong association with your two leading companies, with KoBold and with Ero Copper. So it's very special, close to my heart. I've got lots of reasons to be here and lots of reasons to have a bit of fun. So what I thought I'd do, we're going to change the gears a little bit on this session. It's a little bit different than the other sessions. So we're going to talk about ore systems, or some people would call them mineral systems. So I just want to do a quick level set. If I say those words, ore system or mineral system, who knows exactly what I'm talking about? Put your hand up if you understand what I'm talking about. Yeah, I was worried about that. Great level set. So what we talk about when we talk about mineral systems, ore systems, is the collection of earth processes that collectively concentrate metals from wherever they came, deep in the earth, shallow in the earth, and deposited them in a concentrated mass at a level that's of economic relevance that we can then exploit, we can mine, because the concentration of the metal is significant, is economic. So that's what we mean. It's all of that collection of processes that lead to that concentration. But those collection of processes don't just take the metal and dump it in some place. They dump it in a form, a geological form, which has characteristics. And we sometimes talk about that being the style of the deposit, the style of the mineralization. It's the physical and chemical nature of the mineralization that contains the metals. And for each commodity, there are multiple styles or occurrences or types of mineral deposit for each commodity. And in this case, we're going to pick two. We're going to talk about nickel and lithium because they're very hot commodities. I'll allow you to depart to a couple of other commodities if you feel you need to. But principally, we're going to talk about nickel and lithium. And one of the reasons we do that, one of the reasons we pick that, is they have both of those two commodities have two very important styles of mineralization, which are quite contrasting in terms of their economic and physical and chemical characteristics. And we're going to talk about that, and we're going to talk about it in the context of how does that work then for the value of those deposits and for their interaction with the market and delivering the source of these minerals. So I've got 4 fantastic panelists, and I'd like you to come up and join me on stage, all 4 of you now. I'm not, yeah, give them a round of applause. You've met 2 of them already. You've just met Dave Strang, CEO of Era Copper, and we met earlier Francis MacDonald from Lift. So we've had some introductions to them, but you haven't met Simon Jowitt, who's immediately on my left. Simon Jowitt is Professor of Economic Geology in the University of Nevada, Reno. And he moved there relatively recently from University of Nevada, Las Vegas. And Simon and I go back a long way. We have a certain country of origin in common, as you'll detect when he starts talking. And at the other end, at the far end, is another very close friend and close colleague of mine, Peter Lightfoot. Peter works, he's the chief geologist of nickel for Era Copper. Peter and I shared an office together in graduate school. That was somewhere back in the Pleistocene, for those of you who are geologists, so a long, long time ago. And he's another super amazing person you're going to hear from him. So I'm going to sit down, we're going to get into it, but what I might ask...
Did you miss that, John? You've just moved him from KoBold to Aero.
Thank you. Well done, John. Where's Kurt?
Apologies. Apologies for that. So what we're going to do is we're going to ask each of our panelists here to say a few words. They've got about 5 minutes. I want that they're going to say a few things about the topic that we're discussing today in this session, but I want them to add anything they need to say about themselves, particularly what I want them to tell you, the audience, what gets them really excited about being here today, what gets them excited about the way we're looking now at our business, at mineral deposits and the critical minerals. So we'll start with Simon, and then we'll work from there.
So what did you want me to do again?
Tell us about yourself.
Okay, right. Well, my name, as John's introduced me, and as you can tell from my accent, I'm not from around here. I've lived in Nevada for about 8 years now, though, and my accent hasn't changed all that much. I'm an economic geologist who finds too many different things interesting. So I've worked on a variety of different mineral deposits. I've done quite a lot of work on what you call mineral economics, the economic side of economic geology, looking at supply, demand, and where we get metal resources from, and where we get them from, where we're likely to get them from in the future. And kind of what excites me right now is the fact that probably we're on the cusp of, or already experiencing, something like probably 10, 20, 30 years of increased metal and mineral demand for all sorts of different commodities. It's almost on an unprecedented basis if we're going to do something meaningful about climate change and the energy transition. And that means that that's a huge challenge, but it's a huge opportunity. And I think that's one of the reasons why we're all in this room, because we're thinking about commodities like nickel and lithium and the expansion of the production of those commodities like we haven't seen before. And I think that that's just a fascinating time to be in. And hopefully, and the other thing we need to do is just tell people how fascinating it is and how important the minerals industry is kind of to everyday life and to everything you see in this room. So,
terrific. Thanks very much, Simon. So we'll just work down the line here. So we'll go to you, Francis, and I suspect you'll tell us a little bit about lithium, but feel free to depart if you wish.
Hi, Francis MacDonald, and I had an intro before, but I'm an exploration geologist turned entrepreneur in the mining space, and my background is across most commodities. I worked for Newmont, the biggest gold mining company, for about 10 years, and then branched out into everything and landed in lithium at this point. And so to talk about lithium a little bit, I think it's a very exciting commodity to be in right now, and the reason is that we've never really looked for it, and we've never really needed it in the quantities that we need it right now. And so if you look at electric vehicle demand, it was kind of flat until about 2020, and then it just did a hockey stick and shot way up. And at this point, China has about 47% EV penetration, and we've seen governments commit to EV mandates into the 2030s and 2040s. And because of that, demand for lithium has obviously shot up. And there's been some great discoveries in the last little while, like a company, Patriot Battery Metals in Quebec, found the Corvette deposit, which is a stunning deposit. And this area was actually explored for gold about 15 years ago. And I know one of the geologists that was working there, and he was saying, oh yeah, I remember that outcrop. I was eating lunch in that outcrop, and we saw these big spodumene crystals, but we didn't think it was worth anything. And then fast forward 15 years, and they're raising money at a $2 billion valuation. So the nature of exploration for lithium has just completely changed in the last 3 to 4 years, and so it's a really exciting place to be.
Terrific. And I have to say that early in my career, I was exploring for nickel sulfides in Western Australia, and I was singularly unsuccessful, but I did find a lithium pegmatite, so there you go. Dave.
My name is David Strang. I'm the founder and CEO of Ero Copper Corp. I've been active in the mineral exploration and mining business for the last 25 years, hence the loss of the brown hair, and it's now a nice gray. I've been asked to talk a little bit about nickel. My background, as Jeff mentioned earlier, is mineral economics. So the valuation and supply and demand fundamentals around commodities excite me. Nickel is in a very interesting stage right now with regards to the overall market. Its basic use is still there with regards to the stainless steel business, albeit substitution is starting to enter that space in numerous ways with regards to changes in the nickel price, but that is largely being offset by the greater and greater need for nickel in nickel lithium batteries and the EV market and power storage, et cetera, which was fantastic if you were in the nickel business up until about 18 to 24 months ago. And what we are seeing currently in the world market is Indonesia with a nickel deposit type called nickel laterites, which are only found in the tropical areas of the world, which is essentially concentrations of nickel in saprolitic and limonilic soils. Historically, the industry has always tried to produce nickel from them, and we went through a phase of what we call pressure acid leaching to try and make nickel metal, but historically it's been primarily ferronickel that has been produced, which was fine, and the market was in balance. But then the Indonesian government changed the rules, and the Indonesian government basically said if you want to produce anything, and they used to have direct shipping ore material going into China, you had to put your beneficiation plants in Indonesia. And what that has now resulted in is we now have not only the ferronickel plants being built there, but on the back side of them, nickel matte plants. And these nickel matte plants have now allowed in these historical laterite deposits to allow them to now produce nickel matte, which can now be used in the battery business. So we have seen a significant influx of nickel matte into the marketplace, which has now suppressed the nickel price. And you've seen companies like BHP close some of their operations in Western Australia and other companies around the world. And people are looking at nickel now and going, do we actually want to be in nickel? What is interesting is how we're going to see the response to this in that the one issue with regards to, or two issues with regards to lateritic operations is, number one, they are devastating to the environment. You pull huge amounts of jungle environment down in order to produce laterites in the tropical areas. But the second thing about the issues with regards to the Indonesian operations is they are very carbon intensive, because power in Indonesia is primarily driven by coal-fired power stations. And what we'll see towards the end of this decade is going to be all around the European Union and what its leadership is going to do in terms of what we call the border carbon tax. This is being debated right now within the EU, and if it does come into play, and it certainly will, it will come down to penalizing imports of materials into the European Union that have a high carbon content. And so as we move forward and you start looking at the industry and the marketplace of nickel over the course of the next decade, it's entirely possible we'll be moving into a bifurcation market in which materials coming into Europe, and I think some other Western countries will follow lead with regards to that, will be on the basis of material of low carbon content versus a high carbon content. And so, you know, there's still optimism for nickel. As John and I was talking about earlier, a world-class sulfide nickel project is still a great opportunity set, and certainly we'll probably talk about that a little bit more.
Okay, thanks very much. That was a perfect introduction for Peter. Peter, take it away.
Yes, thank you. Thank you.
That would be good. Thank you. Yeah, I have 40 years of experience in the nickel business. My first engagement was more as a researcher when I was fortunate enough to work on the giant Norilsk ore deposits. These are just formidable ore deposits, billion tons plus of material with exceptionally high grades of nickel, copper, cobalt, platinum, palladium, and gold. Very, very rich. I got the opportunity when just after the Voisey's Bay discovery to join Inco and basically be the person right in there with the discovery of the Eastern Deeps, and then onwards from that into the Reed Brook zone and other deposits in the area. So I've had a very fortunate career with Inco and then with Vale, exploring for nickel. My passion is to find high-grade mineralization and to use the data endowment we have in the most efficient and effective way at securing success. And I was just delighted when this person called Kurt House called me up almost 7 years ago and said, Peter, we want to create a company that explores differently. We want to use the data, we want to understand the ore deposits, create effective hypotheses which can be tested, and we want to revolutionize the way we actually go about exploring. And I've been fortunate to work with KoBold ever since. It's been an absolute journey for me. One of the reasons I have strong hope for nickel, and thank you very much for setting me up, but the grade is king. And this is the entire story. If I was just going out there to find a nickel sulfide ore deposit that was same grade as a nickel laterite, I'd probably go, that's not good. But if I can find the copper, cobalt, and the precious metals in that material, then that's the real winner. These things are not easy to find, and that's why we have to maximize the value from the data and really understand the systems as effectively as possible and make the best possible exploration decisions.
Great, thank you very much. So I just should point out, in case any of you haven't noticed, and I did point this out to Jeff when he asked me if I would moderate this panel, this is the least diverse panel in this meeting today. And that's not because it's 5 males, it's because 4 Brits are sitting on this sitting on the stage, and 1 Canadian. Thanks very much for answering.
1 Canadian,
appreciate
yeah.
your diversity. So what I'd like to do now is go back through the panelists here and ask them to focus on the question about availability of these commodities. That's lithium and nickel, and you can pick the one or both if you prefer. And related to availability is discoverability. How easy is it to discover more of those deposits? So say something about availability, something about discoverability, in your own words.
So I get to go first again.
You can go first again. You can go first again. We're not going to do it always down.
I was going to say
right now. Yeah.
So both lithium and nickel are kind of interesting right now, as a couple of the other panelists have touched on, in that we're seeing a lot of volatility, and that volatility in pricing is driven by, like David mentioned, kind of supply coming in from Indonesia, but also in the lithium market it's being driven by things like policy, so tax breaks on electric vehicles and so on. And I think what I would say is in both sectors, both lithium and nickel, we've got a lot of uncertainty. People have mentioned uncertainty earlier today, but I think that if you look at lithium, for example, we've got the traditional sources of lithium of brines in South America, some in North America. We've got the traditional sources of pegmatites. But there's also the potential for lithium from sediment-hosted or clay-hosted deposits. We've got an awful lot of them in Nevada. None of them are in production as yet, but if they're successfully put into production, then that could be an awful lot of lithium hitting the market in the near future, as I think a couple of people from Ioneer would kind of talk about. But the uncertainty there is it's almost like laterites. We don't know how the processing is going to work. We've found these, there's something like 20 million tons of contained lithium in resources in Nevada right now. And all of that, or the vast majority of that, is in these sediment-hosted deposits like Thacker Pass, like Rhyolite Ridge that Ioneer have. We don't know how the processing is going to play out. So that could be all of a sudden a huge amount of potential lithium hitting the market, or it could be, well, one of the two of these deposits is going to have challenging processing, and that may not actually eventuate. And it's that kind of uncertainty, combined with the uncertainties related to electric vehicle demand and policies affecting that it's kind of really an interesting situation we're finding ourselves in. And the same with nickel, in that we assume that nickel cathodes in lithium-ion batteries are going to be the way forward, but we don't know what the next development is going to be. Is it going to be a different type of cathode which may kind of reduce lithium demand in a market that's already depressed? And these uncertainties on the demand side combined with uncertainties on the supply side in terms of how rapidly nickel and lithium deposits are going to come on stream, what the environmental and social challenges are going to do to all of this, is something that we really need to try and quantify and understand. So there's another level of uncertainty for you to look at, Jeff.
Great, thanks, Simon. So as Simon was talking there were a number of geological words being used to describe these styles of deposits. And so pegmatites were referred to, and then clay-rich sediments were referred to. And it's the styles of the deposits that have these characteristics which may or may not make them easier to find and easier to process, as you were saying.
I was going to say, it's usually my accent that's the problem rather than the words I use. But
Francis, do you want to add to the pegmatite story?
Yeah, sure. So in terms of availability, I think that there's quite a bit of lithium out there, and we saw the supply response was rapid to the demand that came in, and like I was saying, no one's ever really looked for it. And so there are lots of pegmatites, and when we see pegmatites, these are like veins, and they've got a specific mineral called spodumene that has lithium in it, and that's what we're looking for. So as we've gone out and looked for this, we found a lot of it, and these are the simple ones. And to give an example of this, my company, we have a pegmatite province around the city of Yellowknife in Northwest Territories, and I can pull my phone out and I can zoom in on Google Maps and I can show you the things sticking out of the ground. And so like it's literally that obvious, and these are the cherries, the easy picking fruit that are there right now, but we will deplete those, and the next round of exploration we'll have to start looking undercover, and it'll be more similar to more developed commodities like copper or nickel or gold or something like that.
So you mentioned there one of the key minerals, probably the most important, spodumene. So just as a level set, how many people in the room could recognize spodumene if it was put in front of you, other than Bob Linham? Yeah, so it's even for geologists, it's not necessarily an easy mineral to recognize because we haven't seen it or worked with it very often.
I hadn't seen it until about 2.5 years ago.
So that's it's a characteristic of the concentration of lithium, is it occurs with these very coarse but not easily recognizable minerals.
Well, I would say they're typically easily recognizable because they are so coarse. Yeah. And you get crystals 10 centimeters long. So, yeah. And then just one other thing on the mineralogy part of it. So there are other minerals with lithium in them, and one that's been important in the last years is lepidolite. And this is a purple mica, so it's a flat platy mineral. And lepidolite, it has much less lithium in it than spodumene does. So spodumene can have up to 8% Li2O or lithia, and lepidolite generally has about 3% lithia. And so it is a source, but that means that the operating costs are at least twice as high to get the lithium out of lepidolite. But what we saw when the prices went through the roof is that there's a lot of lepidolite out in the world as well, and the Chinese have big lepidolite deposits. They started processing lepidolite, and that ended up being about 10 to 15% of the world's supply. So there is quite a bit of availability. It's going to be driven by pricing, I think, is what's going to be important.
Terrific. So on the first go through, Dave described the nickel laterites, which are causing us a fair amount of grief in terms of nickel supply or oversupply right now. And Peter talked about nickel sulfides. So Dave, do you want to add anything on discovery of laterites or sulfides or anything else for that matter?
Well, having been part of a company and finding one of the largest nickel laterite deposits in the Western Hemisphere in Guatemala, I've added the other side of my head and gray hair of being in the nickel laterite business. And funny enough, we're now at the beginning stages of some nickel sulfide potential discoveries that we're working with Jeff and the Stanford team on in terms of trying to help us understand the opportunity set that we have. And albeit we can't talk too much about it at the moment, but from first standards, it looks like it perhaps may be a generational nickel sulfide district that we've found adjacent to our copper mines in Bahia. It's very, very interesting, but I like to call, as opposed to copper exploration, I like to talk about nickel, particularly sulfide nickel, and you'll get a kick out of this, Peter, as the elusive fairy. Because to find high quality, high grade nickel deposits, you sometimes have to go through a lot of low grade nickel to find that. And there are great stories. Some of the greatest stories of discovery in the mining industry are related to how the elusiveness of finding nickel sulfides, particularly Voisey's Bay, which is one of the great discoveries in history, of how difficult that was, even though they had actually found the basis of the deposit. So it takes a lot of effort. It takes a lot of data. What we're excited about in our relationship with Mineral X, which, based upon what happened 2 days ago in our little session, is going to expand rapidly. So if you want to go to any other departments and start recruiting more aerospace people and all of that, we'd love it with regards to the questions that we're looking to get answered with regards to artificial intelligence, data mining, and all these things that will help us better define and understand the opportunity set we certainly have as a company in the nickel sulfide side of things.
Great. Okay, Peter, now's your shot. Time to tell us about how to find nickel sulfide deposits.
The real challenge out there at the moment is that the supply of nickel is controlled by a very, very small number of companies with very large deposits in some cases. For example, take Norilsk Nickel in Russia. Their polar operations just keep on going. And for the 40 years I've been in nickel, they've been mining high-grade mineralization, and I'm sure there's enough material there to go for the next 20 or 30 years. If you come to a place like Sudbury, 20-odd years ago when I first started working for Inco, Sudbury used to produce over 100 kilotons of nickel a year. Right now they're down to something closer to 50. And the reason for this is that many of the old mines have got deeper and they've reached the point of exhaustion. Some of the remaining mines are exceptionally deep, and it's a limited ability to actually get to the material and mine enough material and drag it up the hoist that limits the production. Other deposits like Jinshuan in China, there's enough material there probably for another 50 years of mining. And new discoveries like Jiahamu will probably enhance the ability of Jinshuan to produce metal. So there's no shortage of metal to keep these companies going in a status quo sort of way. The real challenge is to actually add the next generation of deposits, the entirely new discoveries. And the discoveries in nickel are not easy to make. Take, for example, the Jaguar deposit, which is a hydrothermal nickel deposit in the Carajás belt. That was basically found as a result of drilling a copper soil anomaly. When a bit of nickel turned up in the drill core, it just looked like an odd hydrothermal remobilized style of mineralization, not economically significant. Yet drilling the additional soil anomalies proved up what has turned out to be a very interesting, quite high-grade nickel-copper deposit of an entirely new type. So we've got to keep an open mind from the point of view of not just the traditional models, but we've got to let our geological models allow for new styles of mineralization as well.
Yeah, that's a very good point. So a number of you have heard me talk about quality of deposits types and the importance of quality. And quality is often the concentration, the grade, how much metal there is there. The higher the concentration of metal, the more efficient you are in terms of the amount of rock you move, the amount of waste you generate, et cetera, et cetera. But it's not just concentration or grade, it's also how hard is the material, what's the cost of mining the material? Are you able to do it responsibly? What's the carbon footprint? So I'd like you just to say, we'll go through again and get a few thoughts about which style of deposits here do you think are really the ones that are the most advantageous in terms of production, cost, and sustainability broadly. And we'll start with you, Dave, on that.
It's very easy. Nickel sulfide, high-grade nickel sulfide, the holy grail. But as Peter said, few and far between. The holy grail in mining are what I would term the richest mines. The richest mine in the world is Norilsk in Russia, in terms of value per ton of rock in the ground. And Sudbury is what made Canada. So these, when you do find them, are very, very important to the future, not only of those countries. I mean, Norilsk helped really get Russia going when it started up in the 1940s. But certainly, the other great thing about nickel and high-grade nickel sulfide is your footprint is significantly smaller than what we're seeing, as I said earlier, with the nickel laterites. So yeah, it's a no-brainer. In terms of nickel, is the magmatic sulfides. They're the holy grail.
Francis, some words on nickel? Some words on lithium. Just testing you.
We've got enough nickel up here. Well, for spodumene deposits, and this has rapidly become the largest source of lithium in the world versus lithium brines in South America. For spodumene deposits, there's a lot less variability in terms of grade than other types of mineral deposits, and so they typically range between 1 and 1.5% Li2O or lithia. So in spodumene deposits, there's a lot of other things to consider, the size of the crystals, and it really comes down to the processing rather than the grade a lot of the time. And so, but I think from a source of lithium perspective, spodumene's attractive because you can get it with traditional mining methods. It's got decent grade, and then also you're not using big settling ponds like you do in South America.
Yeah, good point. Simon, do you want to put a bit of context around this quality topic, and particularly in terms of the products that come out and enter the market?
Sure. So you put me. I was thinking about talking about something completely different there, but so could you ask me that question again?
So thinking again about these different styles that we've been talking about of nickel deposits, laterites versus sulfides, and lithium brines versus pegmatites. Give us some thoughts on the value of the material as it enters the market from those different sources.
Well, I think I think Dave mentioned this or alluded to this earlier. I think one of the key things is that what we're talking about here is things that are demand being primarily driven by lithium-ion batteries. And so what you want coming out of a deposit, be it a nickel deposit or a lithium deposit, is something that is ready to put into batteries. That's great if you've got a magmatic sulfide system, a nickel sulfide system. That's great if you've got a lithium pegmatite system. Lithium brines are the same. If you've got a nickel laterite, then the level of processing, as I think Dave mentioned, to get to that level, that quality of material, to go straight into battery manufacturing is a real problem. It takes a lot more energy to get to that level, to get to the purity of that nickel product you need, and that's a real issue because those energy requirements, especially if like the European Union and others start thinking about that, are much higher, and that means you've got a much more costly, potentially, product. But then again, we also need to think about the fact that some of the economies we're talking about, where nickel demand is actually the kind of price doesn't matter. If you're dealing with a command economy like China, the aim is not necessarily to buy the price in some ways doesn't matter as long as it kind of can feed into their manufacturing. And that's one of the key things we need to remember is that, here in the US, we're dealing with a completely different mindset in terms of pricing and things like that than, say, they do with Chinese battery manufacturing and so on. The other thing I was going to say just briefly is that we talk about grade, but one of the things we need to think about, for example, in the nickel side of things, is the waste material. If we're talking about magmatic or nickel sulfide systems, quite often they're hosted by rocks that are rich in a mineral called olivine. And so if you grind up this olivine and turn it into another mineral or an associated mineral called serpentinite or serpentine, and you put it in tailings, that stuff naturally sequesters carbon dioxide. So if we start to think about carbon trading and things like that, then all of a sudden nickel sulfide systems, especially in certain countries, could be way more attractive than laterites. There's a deposit called Mount Keith in Western Australia where their waste material naturally sequesters, 12% of the carbon dioxide emissions generated by mining. And that's not through any kind of enhanced carbon dioxide sequestration. That's just from dumping the stuff out on their tailings pile. And there's a lot of research going on which could actually start to weigh in terms of the carbon dioxide sequestration or carbon neutral nickel mining, which magmatic sulfides are naturally inclined to do, laterites are not.
Yeah, that's a great point. And there's a bit of a plug here for a Vancouver-based startup called Arca, which is working with BHP at Mount Keith to try and enhance that process. So it'll do it naturally. It'll sequester CO2, but if you can speed it up and get more CO2, obviously that's a beneficial thing.
I will say they're not paying me any money though, John. So
Not paying me either. No conflict. Peter, we'll just go back to you, and then I'm going to open it up to the audience and get some audience participation, hopefully. But the question I have for you brings us full circle to why we're here at Mineral X and why you're with KoBold, is what do you see the role of data science in improving our ability to make discoveries, but also, more importantly, perhaps to evaluate the quality of the discoveries in order to seek the grade that we need to be effective?
Yeah, this is a great question. The databases we have and work with in using industry standard tools, we often end up in a situation where we are considering a bit of the data all of the time, but all of the data rarely in one place in a grand unified scheme. The opportunity here that KoBold has of building whole earth models that allow a combination of geochemistry, geology, and geophysics to be modeled around effectively a geologist idea, a concept, a hypothesis around what a target might look like is a fantastic opportunity. I see this from a nickel perspective as a real way of maximizing value and improving chances of discovery in what is a very, very difficult game.
Yeah, and I think it goes beyond discovery. I think it goes obviously into the quality and potential processing. Is there any of the three of you here got anything you want to add to that comments before I open it up? Questions from the floor? Okay, so you first, and then Doris here.
When you're looking at, say, a grassroots nickel sulfide project and evaluating it, what would you think of in terms of kind of threshold energy grade when you think about it? If gold is 1 million or 2 million ounces potential minimum to be what would be equivalent for nickel?
Dave or Peter?
Yeah, I'll have a shot at that. The sorts of grade you're looking for these days have to compete with laterite. And the sort of values for grade of a laterite deposit that are kind of marginal are probably around about 1.25% nickel. I think by the time you're getting up to 1.5, things are promising. 1.75 is quite good. In terms of a laterite target, often the size of these laterite deposits is not fully understood because they've not been drilled off. There's so much material there. Why bother turning more material from resource into reserve? There's very little point. From the point of view of a magmatic sulfide system, I'm looking for a system that has over 250 kilotons of nickel as a real starter. That's the point at which I think a mine can be considered. I'd prefer to be higher than that, obviously, but that's the starting point for me.
Dave, do you want to add?
Yeah, so we're right in the middle of that right now. So we've got opportunity sets in front of us that we're trying to evaluate with respect to that. And obviously what we have is we already have the processing plant in place. So when we're looking at it, it's kind of, nickel's really interesting. And when I was a young person in the industry, I didn't understand why we were able to mine 0.4 copper deposits, but 0.4 nickel deposits don't give the same return. And there's two fundamentals issues with regards to that. Firstly is some of the nickel is encapsulated in silicates, what we call olivines. And the second thing about it is when you're trying to upgrade your nickel and your flotation plants, you don't see the same upgrading as you do in copper, and therefore it's much more difficult on lower grade deposits to try and upgrade them to a saleable concentrate, right? So when we're going around this analysis, I've had my team look at it, and it's interesting, you know, the threshold, as Peter's saying, we're looking at it because we have exposure on surface. It's got to be over 1%. A 1% nickel, if we can find 1% nickel, it's the equivalent of 35%, at current metal prices, 35% higher value than the equivalent 1% copper project in our district, right? So for us, it's a little different. You know, we can look at as small as 10 million tons, but you have to have that threshold nickel grade in order to cover these other issues I said.
Doris, question for you.
See if I can. It's complicated. First, you know, we talk about the old way and the new way. The old way of doing things, opinion biased, and the science biased. In both ways, when you talk to the old way, the new way, they say they've always been doing the new way. But so in both cases, how you determine where you drill first. And then the other quick question is, how, you know, the biggest issue the old way has is access to capital. How can we bridge the new way and the old way? Because we need both to speed things up. And last, what's the future of a geologist?
Francis, do you want to start with that? Say no.
Well, I'll start with the last part first. The future of geology, I think, and geologists, I think is bright because energy transition is going to drive things for the next years. And, you know, I think that there's obviously a lot you can do with data science in order to make things more efficient, but data science is, its foundation is in data. And that means we need to go out and collect this data in order to make models to create targets. And so I think that's the big thing. And from a capital perspective, we have to bring in new sources of capital to collect more data. And the more data we have, the better our targeting or our geologic models will end up being. Did I get most of that?
So where to drill first and what's the future of economic geology? I think the future of economic geology, like was just mentioned, is essentially people who can deal with data. But one of the things we need to do is to actually get people into economic geology. We need to have conversations with young people about the importance of mining without greenwashing. And the fact is, if you want to do anything about climate change, then we're going to need more mining than we have now. And we already mine more right now than at any other point in human history. So that's a different question. But you know, to have a future economic geologist, you need people who want to be economic geologists to begin with. So I think that's an important point. We've heard a lot about data and data science. I think what we need to do is we need to think about actually and what enables a company not just to put the first drill hole in, but also do that in a low uncertainty, rapid manner, so you can get in quickly, you can make a detailed estimation of whether you want to drill more, whether you want to drop it, whether you want to do a deal with somebody else. And that's all we can generate all the data in the world, but if we can't actually do anything with this data, and if you're on an exploration site in a kind of greenfield operation, then people don't have much time. So what they want to do is quite often they'll deal with what they can deal with, then they've already got to site the next drill hole and the next drill hole and the next drill hole. So what we need to do is we need to think about ways of rapidly not just acquiring data, but dealing with the data that we have. We're already saturated. People don't have much time. People can't have expertise in everything. And parachuting consultants in for a couple of days, then leaving with some information that the exploration guys may not actually use is not an effective way. So I think we need to think about what we do with all this data, how we effectively deal with it, and how we train what future economic geologists look like to cope with these data.
I've got a really simple one. How many geologists are in the room? How many mining executives running a company are in the room? Put your hand down. I rest my case. So you're talking about the future. Why are we here today? You know, there are two mining companies that are supporters of Mineral X, right? We are, and I said this yesterday, Eurocopper, Mike, is the only geologist that I know in a mining company that sits in a C-suite position. Geology is the dark arts in the mining industry. And mining engineers and people who generally run the mining companies around the world put the geologists off in the corners. And people with great ideas get stymied. What is important about today and what is important about what Mineral X is doing and what is this new intellectual capital is looking at our industry with fresh eyes. I hate to say it, we're dinosaurs. And we as an industry have not progressed in a way that we should have progressed. And what is great about this in this forum, and I really hope, Jeff, that we're getting a bigger hole next year and we've got more people coming to this, is related to this. The mining industry is, I believe, is about to go through a step change in how it thinks, both from a social dynamic perspective as well as a discovery perspective. And there are people in this room, and particularly the young people in this room, who are going to make dynamic change to our industry. And that's the excitement, that's the opportunity that we have as a group. This, I hope, people will talk about in the 10 years from now in the mining industry is the forefront of how things changed from what we've been doing for the last 40, 50 years, because it hasn't been an exciting industry. You know, many of us didn't ever want to show business cards. Well, certainly when I came to reunions, people go, "What do you do, Dave?" "I work in Vancouver." You know, so, you know, it is changing, and what is becoming abundantly clear with regards to the future, if we want a future for our children, we need critical minerals. We need to do it in a sustained, environmentally friendly way, but the only way we're going to be able to do that is with new technology and new thinking.
Here, here. Next question. Yeah, a question there.
That's a tough act to follow, David. Question for Peter. You made a previous comment that we need to keep our minds open to new types of deposits. How does AI fit into that, where AI really prefers things inside the envelope of what it knows?
Yeah, I think the answer to this is we have to maximize the amount of information we have about the different ore systems and build those into our models. There comes a point where you can't train a model unless you have no data, that's for sure. But if you have a series of very, very well constrained concepts, then you have a basis to select a terrain. If you have a basis to select a terrain, then you have a way of actually starting your exploration program. I think the trick is to try and pull that thread out of the data and use it in an AI-informed decision process.
Great answer. Yeah, we got one in the back.
Yeah, David, I definitely appreciate your last comment. Yeah, there's not enough talk about the further downstream in this. And I'm DeQuan Bruce. I represent Westwind Elements, head of government affairs, and we're building the U.S.'s first nickel refinery in Oklahoma. And no one talks about, you know, the further downstream you go and the processing technology that's required. But we build off of Inco and Vale's technology. You had mentioned about, I'm sorry, I had to write down a bunch of questions. You mentioned about, you know, unlocking, you know, the potential with sulfides. I'm curious, you know, for you all, where do you see the greatest potential geographically for nickel exploration? And then what can, you know, governments in those jurisdictions be doing to help unlock that potential? Whether it's public-private investment or, you know, measures to de-risk, like what do you see as the greatest, you know, future, but also maybe the challenges that impede nickel exploration and then potentially refining?
Peter.
Yeah, so there are certain geological terrains on the planet that have really high potential. rift settings, the roots of large igneous provinces, and the edges of very old domains of crustal material are great places where mantle-derived magmas can focus and where the processes that create these incredibly valuable ore deposits are actually localized. These are the environments you want to be in, and there are certain countries that are really well endowed with these geological environments. Take for example the Yilgarn Craton or the Superior Craton. The Superior Craton has 4 giant camps around its edge. There's no reason to believe there's still not one or more of those beasts to be found, and probably a lot more smaller deposits within that geological setting. So I think that's the prize. Messaging it, that's the way of getting the story out there and getting the level of enthusiasm in investors to actually put the money into it and start again doing proper greenfield exploration. Don't expect everything to come out of existing camps.
Simon, do you want to add?
Yeah, I think that there's wherever people kind of say, "Oh, don't look there," is probably worth looking at. I mean, there's been discoveries like Nova Bollinger in Australia where people have said, "Well, that's not necessarily a very prospective terrain for nickel," but all of a sudden there's a pretty decent nickel deposit there. There's other examples like that. There's examples of I can't remember the name of it, but the recent discovery actually pretty close to Perth in Western Australia. The key thing is to go in with an open mind and think about the processes that Peter's mentioned and say, and others, and just say, okay, well, where are these processes likely to happen? Just because somebody says that, 20 years ago we thought this wasn't a place to look for nickel or lithium or whatever, I think we need to kind of go back and revisit some of those areas that have been considered no-go zones and actually see if that's justified or not. And reevaluate quite a lot of the areas, especially with more and more we know about these mineral systems. So I think there's a lot of potential out there. And I think the other thing, the previous session we talked about the geological surveys, the more pre-competitive data there is, the more all of a sudden areas start to open up. I'll put a plug in for Nevada. I think Nevada's underexplored because we don't have the pre-competitive geological, geophysical data yet that we could have compared to places like Western Australia where the data saturation is higher.
Possibly overexplored for gold?
No. there's gold in them there hills, as they say.
Francis, do you want to add anything?
I was just going to say go under the pediment in Nevada. And
we've looked at the ranges, we haven't looked at the basins yet. So
we'll take one more quick. Karen, go in there first.
Just a quick question, but first I think, Simon, you need to learn to say Nevada.
When I become good luck. When I become a U.S. citizen, I might make the change. We'll see.
Okay. I just want to ask, in terms of the mineral resources sector, and given the critical minerals dilemma at the moment, which is almost the whole periodic table as we go forward, nobody's really said much about characterization data. We have core scanning. We have all kinds of tools now at the very earliest stages of exploration to start gathering a whole lot of information and data. And I wonder if you guys could comment on multi-element or characterization information, how it might transform how we do things.
Francis, do you want to start that?
I always start thinking about scale is the first place to start, and it depends on what are you looking for? Are you looking for a new mineral deposit in a greenfields area, or are you looking to tease out something else from an already developed area? And so let's start with the greenfields part of it. Greenfields exploration is driven by data, and we need pre-competitive data sets. And when we say this, these are big country scale data sets. It could be geology maps or remote sensing or things like this, and that helps you define where you want to go. But then there's a lot of, I call them bells and whistles of fancy things you can do. And I think I said this before at some point, but if I was given an option to do hyperspectral on everything, on every piece of core that came out of the ground, or I drill 50% more drill holes, I would always go with more drill holes. And that's a different perspective, though, when you're at a mine site or in a brownfields site, where I think data density is more, potentially more important. And I think that's when you can really start to make correlations when you have high data density like that. But in the early stages, you're really just looking for sniffs of something. And the more area you can cover is more important than capturing more data on a specific piece of rock, in my opinion.
Dave, a quick comment.
A quick one is just you should talk to Jeff. We're doing that work with Jeff. We've drilled one nickel deposit so far, and we're now looking at all the sorts of, and Jeff's got a postdoc working on this in the room. Where's Adil? Who's working on this, looking for associations and relative associations to see where we can now take that data and then take it into our exploration program to see if we can find similar types of relationships between geochemistry, soil sampling, plus some of the electromagnetics, and trying to see associations. So certainly we're working sort of that, and Jeff and the team are doing some of that sort of cutting edge kind of work for us.
So we're going to wrap it up. Just want to try and summarize a few kind of key thoughts from our panelists here. What I hope you've heard, whether you understand the geological context or not, is that there are earth processes that make concentrations of metals in the earth, which is what we seek and exploit. And those processes determine the character of that mineralization, whether it's a laterite or a sulfide, whether it's a pegmatite or a brine. It's those processes that create the nature of the material and then determine its economic viability, its characterization, the character of it, which Karen was referring to just now, and even its sustainability, then the nature of the products. So yes, we need economic geologists because they're the people who understand the processes that will start that whole thing. But we need economic geologists who are very comfortable working with a broad group of people, particularly with data scientists who can help us get far more out of our work than previously, hitherto, and can do it far more efficiently and effectively. And if we can do all of that, we will change this industry, by damn it. Thanks very much.